Hello, everybody, and welcome to the March 2026 Inventors Gathering, where we have a real treat that's going to be very educational to me and hopefully to other people. We have here Vittorio Lumare, who is an Italian inventor and roboticist who has made, I think, I'm not an expert, one of the best robotic hands in the world that's completely open source. And he's been very kind to get up in the middle of the night in Italy. It's 8 o'clock here in Texas, and speak to us, although he won't be coming on camera after I play a video about his thing. So let me just briefly introduce it, although I don't know Vittorio as well as I would like to. Vittorio has for some time been making an open source hand, a mechanical hand which can perform gestures and grasp things, which can be used both as a robotic hand and, very excitingly to me, as a prosthesis for people who have lost their hands. He recently joined Public Invention in a way that's different than some of our other projects. Often a public invention project is based on an idea that I had or someone else had, and we build a team around it. Vittorio has been working on this for a very long time. But he decided to kind of join Public Invention because thanks to a woman who's in this meeting, Miriam, we've gotten very good at recruiting volunteers. And so we've been able to recruit 2 volunteers who have started working on the Yeah hand, which Vittorio has implemented. It used to be called the Rebelia hand, but we're now calling it the Yeah hand. Since it's early days, I'm not going to ask exactly how those volunteers are going, but the idea is that it was already an open source project, and by kind of forming an alliance with Public Invention, since everything's open source, there's no sense of ownership, but in forming an alliance with Public Invention, even though Vittorio is not getting paid in any way, we are paying for some supplies which he needs and trying to get him volunteers who can make better use of his invention. Okay. Now, since it's the middle of the night, I'm going to play a video, which is a very good video explaining his work. Some of you may have already seen this. It was recorded at a different conference. I know Victoria was at that conference, and I'm just going to share it now.
That gets me every time. Okay, so now we'll have another virtual talk by Vittorio Lumare. So Vittorio got his master's at Politecnico di Milano, Italy, and is a robotics engineer with 12 years of experience. After his master's, he began research and development in indoor positioning robotics and many other projects around Italy and the UK, working mainly with Moli Robotics. He's now a freelance consultant in robotics and computer science, working for both local and remote clients, and started his personal open source project, Rebelia, an open source robotic hand for humans and robots, which he will now share more about today. Please welcome his virtual talk titled Rebelia, a hand for humans and robots.
I am Vittorio Lumare, a robotics engineer, and I started this project of developing a myoelectric hand because I have a friend which has a transradial amputation, and he explained me he couldn't afford advanced myoelectric hands with many degrees of freedom, sensors, because they cost too much, they are bulky. The only one, the national health system in Italy, the only myoelectric one which is given to the people by the system for free, is very old and not advanced at all. It has only 1 degree of freedom. So we started to check if it was possible to make a better hand with low cost, because now the technology it's very cheaper than before. There are products ready on the market. You don't have to invent one motor. You can reuse some servo motors that already exist. So we started trying, and we ended up with one design which can it's compatible with his amputation, because depending on the length of the remaining limb, you have less or more space. So in this case, he had this space. We put in this part all the electronics and actuator we needed, and all the rest is just tendons and plastic part pulled by the tendon. So we ended up with a mechanical design, very simple. It has one tendon for closing the finger and another tendon to extend. We made a lot of research and tests to prevent lateral movement. We only want to move it forward and be rigid in all the parts except the flexible joints. And also we made in a way it's easy to replace covers. We can have covers on it. This is the new version actually. There are two versions. The first one has been already released, open source, and the next one will be done soon when it's finalized. We had to improve many things to make the device usable. The device has two sensors. I can show here, it will be shown even better afterwards, but it's just the first prototype we made. It has two sensors inside, and this sensor can detect the muscle movement of the flexor of and extensor of the wrist. So when you use the flexor muscle, it will flex the wrist. These people don't have the wrist. They are only the remaining muscle, but these two muscles often are still active, despite this kind of people often loses the control of all the other muscles. So depending on how many muscles you have a better control or a simpler control. My friend had just two muscles available, the closer one and the flexor one, the extensor one, sorry. So we put two MG sensors, electromagnetic, myographic sensors. So they are just external, put on the finger, on the skin, contact sensors. They don't need liquid or any treatment of the surface. You can just put them on the muscle always in the same place and position, and they will detect the muscle activity. We put on the closure, one on the extensor muscle, and when the closure muscle activates, the hand starts pulling with the servo motor the tendon which closes the finger. As soon as you start doing the opposite, activating the opposite muscle, it starts going back until you stop doing anything. So for example, if I want to grasp an object, I have to exert some force on this muscle, the flexor muscle, and it starts closing, and at some point I stop doing anything and the hand will keep the grasp. And this is useful because the people don't want to keep exerting force while grasping an object and moving it. They want to just close, stop acting, stop moving muscles, and the hand must keep the grasp. This works very well. We tested it, and there are two thresholds, with one threshold for closing, one for opening, and this is applied to all the fingers simultaneously. If some person has more muscle available, we can add more MG sensors to control independent fingers, as well as we already can see with many advanced myoelectric hands in the commercial field. But this kind of hands cost a lot. Not many people can use them because they don't have so many muscles available. Whenever this happens, we are ready to integrate more sensor in our version, which is low cost. So instead of having a hand which costs 20,000 euro, we can have a hand which costs 5,000, and the actual cost of the components is only 200 pounds, and another 200 of man work. So it's a very cheap device. The reason why it costs a lot because the certification, the regulations In Europe it's called MDR. They force the companies, it's right, I mean, it's required because they have to implement many procedures and checks and external audition in order to be able to deliver a product which is always the same, with the same characteristics, with the same safety measures. And so to have a reliable and safe medical device, the cost is a lot, because this certification cost more than 40,000 initially, euro, US dollars, pretty much the same. And then you have another expenses for the insurance and so on. So the price of a hand triplicates due to this. So people, also company want to get more earning, and so the price increase. In all this scenario, we thought we can reduce at least the engineering cost and some earnings for the company. So we have a product which it still gives promises to the company a successful business, but with reduced cost. And because we release open source, the engineering cost now is solved, already done for everybody. Everybody can get and start it. You can sell it as well. It's not non-commercial license. You can also sell it. So anybody in the world can create, print this hand assembly and then sell or give for free. And we are okay with this because the intent is to make the market so competitive that anybody can do easily the hand, and all improvement must be shared because it's a viral license. So you want to do it, you have to release it. You want to improve it and make money with it, you have to release it. You do something which improve the hand so much, everybody will get this because you must release it. And then so we will end up having very advanced robotics hand in all the world, and everybody can do, many companies will be able to do this, and the price will go down very much. So this is the intent of the project. The device works, we tested many ways. We also made some effort for conditioning the signal, because there is a much noise to detect the muscle activity, and usually there are many steps. You do convolution, you do the envelope. We ended up with an FFT filtering which isolates the band that we need, and then with some thresholding we could obtain a signal and a reliable control. So when my friend which tested the hand, this was made for him, unfortunately he cannot use it anymore because he made some gym and his arm grew a bit, doesn't fit anymore. But he can control very well, and when only he decides to close the finger, they close, and if decide to open, they open. If he doesn't want to move them, they don't move. So we tested many times, it's reliable. There are two batteries inside in this panel, and now there are screws to remove. We're gonna make the next version more easy, so you don't have to use screw to remove the panel and replace the batteries. And so we made a new model. It's no release yet, will be. It has all these advanced features. You can remove the plastic very easily and put them back. And also this part, if you want to maintain the tendons, do some change, it's very easy. And also you can change the color, and you can change the color, everything. And so this is very versatile project, and after the signal conditioning and all this improvement, we tested it, and I have to say we were surprised by the result. And so we started thinking we can start distribute in some way, but the regulation makes this impossible because you have to do a very expensive process. And then we started to concentrate on the robotic version without the socket, only for robots, to get a product at low price without all this regulation and costs, with the intent of improving it and obtaining a successful business which can produce earnings and give us the possibility to be on the market, to be positive in business. And so this should help to obtain a reliable product in a few years with earnings which permit us to also start the other project, the prosthetic version, which now it's impossible, at least for me and my small team. So the intent is to have two products, the robotic products and the prosthetic one, both open source, both you can do, improve, copy, sell, whatever you want. We will do the same. Everybody, we hope, will do the same, and so we have many versions which will probably converge into a very advanced one, which anybody can still get and produce and sell. So this is a solution which is effective. My friend used it. He could grasp many objects. Could open a bottle of water. It could open a door, pressing buttons, grasping objects very reliably. But in order to get this, we had to do several improvements. And the most important one we discovered was the grip. So having a hand which can close reliably and you can control it reliably, and you can decide I want to close it more, a bit less. It's good. It adapts to the object because it has tendons, not gears, so it basically closes until it touches all the part of the object. It's closing over it. But there was a big problem. The object tends to slip. There was no grip. So our skin has a very good grip. Many robotic hands are made of silicone, which is the best material for the grip. And so we added some pads on the hand, initially of rubber in the first prototype. And the current one, you have to glue the rubber pieces to the palm, to the fingertips, and you have a very good grip over the objects. This helped us to grasp an object which couldn't be possible, even object large like this, like 15 centimeter diameter. So it's a big hand. I made it over my friend's hands and mine, which are basically the same size. So it has a size. We plan to make it of different size, obviously. And in the new version, we will use silicone pads, which cannot be printed at the moment, or you can with some special printers. It's not easy to have this kind of equipment. So we made in a way that anybody can do. And we print the finger with the TPU, flexible. It has flexible joints with also PLA inside materials to make the print more solid and to prevent some distortion of the finger. So it can move only in one way that we want. And then the final material is cast by manual injection molding. So we prepare a cast and then put exactly, it matches the face of the front of the finger we wanna produce, and then inject with the syringe the liquid silicone, and then it solidify after some hour. And this is the most advanced kind of piece we made for this hand, and it will be delivered in the new version. The version number 2 is not yet delivered. We have to improve it, but the expectations are good because our test prove it works very well, and we will put even more features, and all will be released by open source. So we will have we can anticipate we will have a hand which can auto calibrate, which can limit if the temperature raises too much, preventing risk of burning, risk of fire, risk of damaging the motors, and also limiting the maximum tension for the tendons, preventing the breakage, the uncalibration. Even though the hand will calibrate anyway automatically every time you start it, sometimes it may need some manutention, some maintenance. So you have to open the back panel and register some tendon after some months of usage, And to make this even easier, we made all snap fit, so there are no screws to remove. You just remove by pressing, the plastic pops up, and you can maintain the hand. In the rarely times is needed, because again, the auto calibration and the force limitation will make sure there will be no need so much of doing this. It will happen very rarely. And all this system we made, this control, also provide another good functionality, that you can grasp objects without knowing the shape, and the hand adapts to the object automatically, stopping the force exerted by each motor when it surpasses the threshold that we want. So if at some point I want to pick a very fragile object like an egg, I just have to set the limit of the force lower to the minimal level, and the hand will start closing around the object. When it feels a bit of resistance, it will stop suddenly. And I can choose different levels of closure strength, up to the maximum limit, over which one it will create problems for the hand integrity. So we cannot go over the threshold, but the threshold is very high. So the hand is strong, it will be durable, auto-calibrated, and I hope this will be appreciated, and many people can contribute to this project to make hands even more accessible in all the world. Thank you for watching. Bye.
Okay, thank you, Vittorio. I notice your volunteer Oscar is here. Vittorio, why don't you come off mic and say hello?
Hello. Hello, everybody.
Oscar, why don't you say hello, since you're working on this project as well? I don't know how much you've gotten done.
Hi, everyone. Yeah, right now, this is my first time starting a project from the ground up, which is pretty cool because I've never done something like that. I've only worked with legacy code, but yeah,
Okay.
so right now I'm just working on the app of it to connect it from the back end and the firmware and all that stuff.
Okay,
With the front
we may
end.
have some questions for you later, but right now, does anyone have any questions for Vittorio? Okay, well, I'd like to start, and I'd just like to say it's a beautiful vision that Vittorio has here. Of course, he's not the first person to do it, but he may be more advanced than almost anyone else in the world in the idea of making an open source machine in which a large community of people potentially contribute, hardware inventions, software improvements, innovations, even material innovations to the hand itself, while companies are attempting to make a profit. Now, Public Invention is a US 501c3 nonprofit. We don't try to make a profit, and we're not, for example, interested in directly manufacturing the Yeah Hand ourselves. However, we're completely friendly to the idea of a commercial product being made, because in my estimation, although I'm very progressive, I'm very liberal, you're not going to be able to supply physical devices to people who need them all around the world, without creating a fairly traditional firm that operates on a for-profit basis, in order to deal with like liability and capitalization and the other kinds of problems that address a real firm. And once again, I thank Vittorio because it's the middle of the night in Italy, and I really appreciate him being up. Vittorio, can you speak a little to what your commercial plans are, and maybe how far away you think you are from let's say manufacturing 100 Yeah Hands?
Yes, well, 100, yeah. I will be ready, I think, after we continue this very good work we are doing with the volunteers, and because I need so much their help in order to make the hand reliable, because at the moment the tests I could make are limited, and also was just me and other people, but the main development was by me. So now having even a few people, and they can grow, maybe can be many, working on this project, it will be very, very useful. And I think this can bring the hand to a ready product in optimistically in 1 year. Can be even just some more 2 years, but then I'm sure it will be usable, and I can start, and anybody can start to produce and sell at any version, variation, or price, anything. And one can think, okay, but then do you think some big company can also take advantage? I'm eager they do this, because then it means it's valuable, and then at which price they could sell it very much more. I don't think so, because the competition is there then. And this is a very good thing, because we'll get all the hands prices low generally. This is the intent of the project, basically.
Yeah, I really like that idea, and competition is really good when when large firms are competing with small firms, nobody can quite cease to innovate, right? Because everybody has to keep making a better product, and in the end, it's the amputees who will benefit from it. So I don't know if you're ready to describe the work that Oscar has been doing, but I'd like, maybe you can speak to what Oscar's been doing, or let Oscar speak to that, and also answer the question. I know at first I only wanted you to have 2 volunteers because we haven't had any practice managing them. But in a perfect world, how many volunteers would you like to have working on this, Vittorio?
Well, for now, I think it would be good to have some from the mechanical area in order to make some improvements that I could have make some mistake in the design, probably. And for now, this could be a big improvement. Another thing, I would need somebody to test variations, because there are other things we can do, like put other motors, make the wrists a bit larger but shorter, and with more motors, given a shorter payload, the radius from the end effector is shorter, you get easier to have more payload for the arm. And so, yeah, so this concept and these possible features need more volunteer for sure. I would say even more for now, just other 3, 4 could be okay. I don't know how many I can manage, but if then they grow, if there is some other volunteer can co-manage them with me, it could be even more. Why not?
Okay, yeah, at Public Invention, we just kind of feel our way through and learn how to do things. But we may try to recruit you. If there are any mechanical engineers who heard that, send an email to me, read.robert that's read.robert at pubinv.org, or read.robert@gmail.com, and we can talk about volunteering. Vittorio, what have you tasked Oscar with doing?
Oh yeah, what I gave him is to make the application we need for controlling the hand remotely. So the idea is we can put as we thought to do in some school. In this school, there could be this hand with this camera and powered and connected to the system. And anybody who can access to this web application remotely from a smartphone or computer can control the hand remotely and see how it moves. And this could be educational, I think.
And that's a beautiful vision as well, right? Because it means people all over the world who have an interest in this, they wouldn't even have to have a physical Yeah hand. They could robotically, so to speak, watch it on video. They could program new gestures, which I believe is part of what you want to do. Can you speak a little to Vittorio to kind of, I don't know if you'd call it research or development, but the development that you want to do of new grasping gestures, or maybe some other gesture. I don't know.
Yes. Yes, so yeah, what I experienced by using this hand is that some grasps are difficult and require different design or way to move the actuators. Can be necessary more than one. For example, to make the pinch grasp reliable, the pinch grasp is the one you use just the index and the thumb. You usually, yes, as you can see, your index finger is straight, is not flexed, and you want to keep like that to be effective in this gesture. But what happens with the tendon driven, with just one tendon, it folds on itself, and then you lose the contact with the. So to obtain this, there would have been a need of imitating more the human hand by putting another tendon on the back, which keeps the finger straight, so you can close it but keeping it straight. This is not doable with the current hand. I mean, it can be done until to some exert, because I made the middle joint thicker, and this make more difficult to flex it, yeah, in the first time. But you can pick an object not so strongly. That's the limitation at the moment. So I would like to improve the hand with another motor, at least for the index finger, consider different design to achieve this better performance in the grasping, because there's not just the pinch grasp, also other grasps are difficult. For example, you cannot use a spray like the Montana spray, the one you use for coloring graffiti. You can't, because the index finger would need to laterally move aside, yeah, in order to match the cup and press it. And at the moment, the current hand doesn't have the lateral movement; just they are close together. The thing, so this could be another improvement. So yeah, there is a lot of things we could improve. The goal is to make it still easy to replicate by anybody, and cheap. Also the production, well, production can be flexible, because even if it's not, we come to have versions which are not really feasible because the production will cost too much. I don't care if it's feasible for somebody who can use it and want by do it yourself. It's still good. Also, there could be version, and we need them for making them easy to produce. If you have to assemble the hand, it's very much difficult. Then this is a problem, also for making it very low cost.
Okay.
Yeah.
So from my point of view as kind of a supervisor, one of the interesting things there is that programming new gestures, although it requires the hand for testing, obviously, is primarily a software issue, right? It's a programming issue.
Yes.
And that brings me to something that Miriam has asked in the chat here. Miriam Castillo asked, which testing is missing or wanted to see happening in the short term? And I guess she means both testing of the gestures and testing of the function of the hand.
Yes, yeah. This is something we are working on, and with the current design, with all the limitation it has, we can still add more gestures. For example, the pinch grasp I was saying, it works if until some limit of the force. You cannot use high force with this gesture, but if you have to get an object which is not very, very heavy, you can still use it. And we wanted to add, and that's why the new volunteer is working on this. We work on this, Sampath. He will add the tripod grasp, which is the one you use the middle finger, the index finger, and the thumb. So you can use to pick spheres or object with a regular shape, for example. This is a very very useful one.
Most of the testing at this point is what you'd call gesture testing, not the mechanical testing of the hand itself.
Yes. So yeah, because every design can be better or worse for some gesture, but in its range of gesture, of possible gesture, we want to fill all the gaps. So if there is something we can do it with the current design, and we hadn't, we want to do it because it's going to increase the versatility of the hand.
Okay, thank you very much. Lawrence Kinchlow writes, how does this hand compare to the open source DEX hand, DEX? He gives a link to it, or the InMove 2 open source hand, and he gives a link to that. And he writes, my guess is that most of these projects look abandoned or to be a one-off project.
I'm checking the links. Yeah, actually, the InMove hand, I know it, but I'm not sure. It doesn't seem to be ready for real world application. It's part of a big robot. It's a humanoid robot, which is a very incredible project. I don't think it's been tailored to be used in a real world as a hand because it's a part of a more bigger project. About the other one, I'm checking the link. Just 1 second.
So while Vittorio's doing that, let me comment on something. Like a lot of people, I would like to be smart, but I think something that Thomas Edison said is really true. Invention is 1% inspiration and 99% perspiration. One of the things when it comes to something like building a robotic hand, which doesn't necessarily require new technology, is that the team that just is the most persistent and keeps working at it and keeps making improvements again and again and again and constantly making improvements is a team that wins, right? At the moment, if Vittorio decided not to work with Public Invention, there would be no way that we could continue the project without him. But in principle, what Public Invention is trying to do is to provide continuity so that projects can go on for a long time, even if the leader of the team has to take a vacation or take some time off or something like that, right? So it's not our preferred mode of working, but we would like to keep persistent teams. And Public Invention built, I think, the best open source ventilator in the world. Not necessarily the best ventilator, but the best truly open source ventilator, not because we were better than anybody else, but just because we kept working at it longer than anybody else. And we may bring that project back shortly. Did you find that other hand, Vittorio?
Yes, I checked it. It's an impressive project, and I see as also the lateral movement. I would say the difference here is they can use smaller motors because their force is lower. Each finger has 10 Newton, so it's about like 1 kilo. And yeah, it means my hand has 25 kilos per finger, so it's a different application range. And I want to do the same thing, but as I said before, it could imply to add more space around the wrist, which is doable. We have to just think about it. And so, yeah, the price of this hand extend is also impressive, similar to the one I made. And yeah, I like the project because sometimes you can use also hand. You don't have to use application with very much force. Then it could be better to have a model with smaller motors, and we can also consider to get inspiration from it.
Well, it'd be particularly beautiful if if you could take some ideas from that project and that project could take some ideas from your project. Since everything is open source, that's possible from a legal and an intellectual point of view. And let me just say one thing. I have a PhD, and when I was in graduate school, there were people who were concerned about being scooped, or the idea that someone else would invent the thing that they were working on. And you know, there have been a lot of cases in history of people inventing something at almost the same time, but I think it's a real mistake to be afraid of it. You know, if two teams are working on the same idea, even the same basic approach to a robotic hand, they're almost certainly not going to make the same design decisions. And so in almost every situation, except maybe outside pure mathematics, um, certainly when it comes to mechanical engineering, you know, it's better to have more teams trying to solve the problem. Now, that might look like wasted energy, but in fact, by making everything open source and following the policy that we at Public Invention call working in the light, where you show people as you're going what you're doing, you make it possible for two teams to sort of appear to be competing and that they're both trying to build the best hand, but they're actually cooperating because they're exchanging information and taking ideas from each other. So I think it's a really beautiful thing. Oscar, would you like to describe what I think you've only been working for 6 weeks on this project, maybe. Can you say a little bit about what you've done?
Yeah, it's probably just a little bit less. But like I was saying earlier, so basically what Vittorio wants me to do is he just wants me to do the communication between the hand and the Bluetooth and the web app. So just like a in between. So we can go ahead and anybody just go on the website and start working on it themselves as well. And that's basically what I'm doing. Right now I'm just doing I opened the project. Like I said, this is my first time starting a project from the ground up, but it's a learning curve, but it's not too difficult. You just need to make sure you're doing all the documentation and all that. That's all, mostly what I've been working on. But I already I already started 5 issues. And I'm looking at this, adding the documentation, just making sure everything's good. And doesn't seem too difficult. I'm hoping I can finish this pretty fast so I can go ahead and maybe jump in and do part of the gestures and like add on to the volunteering stuff as well that Vittorio was
Yeah,
talking about.
of course, of course.
Yeah, so I'm hoping I can finish this pretty fast and then go ahead and jump and do that. Yeah, that's kind of mostly what I've been working on.
Well, excellent. And as I understand it, your work may make it easier for other people to join the team because they'll be able to use the hand remotely to program gestures, right? So in a way, your work is somewhat foundational.
Yes.
So thank you very much for doing that. Does the audience have any questions for Vittorio or Oscar? Okay, well, your video sort of answered this, Vittorio, but I wonder if you could just maybe talk a little bit more about why you said in your video that you were a robotics engineer and you saw an opportunity to make a better hand. You know, why did you decide to make an open source hand? And you know, when did you what motivated you to start this project? Was it to help your friend who has lost his hand, or something more general?
So yeah, I have to say, I have to be honest. It was the main reason was, as an engineer, I knew how could have been cheap and easy to make a product like this, and I was really shocked by the prices. For me, it wasn't acceptable, crazy. Like, why? Maybe I'm wrong. Maybe it's so complicated. Yeah, it is complicated. Yeah, but it's not like that. The prices are crazy. So yeah, this was the main reason. And then I thought to my friend, which was talking about, there is this hand, it's so cool, so I want to use, but it costs to 25,000. That my friend without the hand. So then I thought, why this? So let's try. And then trying, when you try and then you continue doing the thing, you know.
Yeah. Yeah. Well, and that's one thing that happens when in open source projects. Sometimes open source projects are created to lower the price of things. But then, as happened with the world of 3D printing, the open source projects, because so many people participate in them, start to produce more innovations than the universities and research labs from, which often are the first people to build something, but often at a price which, it is not accessible to many people. Along those lines, Miriam Castillo writes, are you trying to reach out to universities or research centers so that you can test the web app and get feedback about improvements with the grass?
Yes, it would be very useful because it's an easier approach. One thing is to ask some university to buy hands like from one day to the other. But another thing is to just say you can test free this remotely and start experimenting with the hand and program it as well. We can add also the feature for we can do many things remotely with the hand. And then after this, some university can think to adopt it for the research if you find it useful. So yeah, I think it's a bridge, it's a new bridge we have with other people. Yeah.
Yeah, if universities found it useful for education, then it would be very valuable because they would be doing research at the same time they're benefiting from the educational aspect, at the same time that their research is benefiting amputees in the future or people who are using it in a robotic sense, not who are not using it as a prosthesis. So I view it as a virtuous cycle. Here at Public Invention, we like to write academic papers whenever we can. We try to do peer-reviewed publishing. It's not, a lot of times when you write a paper, very few people read it. So in some ways, the GitHub repository, it's open right now, the Rebelia and Yeah Hand GitHub repository that Vittorio opened is free and public, and anyone in the world can see it, and learn from the project, whether they choose to build it or build on it or not. And of course, that's the way we always work at Public Invention. All of our projects are visible to the public even before they're any good, right? Even before they're sort of usable in any sense, because I believe it's very valuable for people to see a project while it's in progress. Do we have any other questions for Vittorio or Oscar?
Actually, I wanted to say something. Another thing we could think to do is on the prosthetic side, even if it's not commercial, cannot be used by normal people because it's not tested. It's usable for testing and improving the robotic hands, prosthetic hands in the clinics, because they can use them if they are not certified. That's the way it's done. Is the prosthetic devices must be tested in the clinics in order to get better and to pass the clinical trial. It's called. Everybody I think has some experience about this area, and it's very interesting because it can be used there, and then many versions can be improved also on that side, because there are improvements. It's not just the upper part of the hand. A very important part is the socket. There are better ways to make it more adaptable, flexible, transpirable for the air. So yeah, it could be very interesting if we could do also some work in parallel, even if it's not meant to be certified. It's gonna be one day.
Right. Okay. Megan Cadena has written, what made the team decide to work with Public Invention?
Because I was really impressed that I found somebody like me who had the same ideas of the technology must be shared, must be public. Otherwise, you are limiting it.
Right.
Yeah,
Right.
this was very, very incredible. When I saw this website, I said, no, it exists. Great. And then I started investigating and seeing, and I contacted you, and yeah, it was great.
Miriam asked, how did you find Public Invention? Did you find a website or did Victoria mention it at that conference?
Yes, I basically was searching for this kind of company, of organization, somebody, because I am a friend of mine, already had a similar idea in the past. And someday I said, okay, let's see if there's somebody who made this service, this organization. And then I found even others, I don't remember, but there was closed project maybe or something else, and yours was the most credible and the one with much more projects than the others. So yeah, I decided to try to start with Public Invention.
Okay, well, Vittorio had to get up in the middle of the night in Italy. I really appreciate him. Thank you again, Vittorio, for being here.
It was an honor to participate in this event.
Let us hope that in 3 years, we can all say we helped somebody have a good hand that they wouldn't have had if we hadn't worked on this. Whether it's made by Vittorio or manufactured by someone who never contacts us and doesn't tell us what they're doing, that would be really good. Before I adjourn, let me just say one thing. Public Invention has planned an in real life conference in Austin, Texas on June 13th. It's going to be in a beautiful event space in the Central Library, which we've rented. The space seats 300 people. We're hoping to have 100 there, which may be a little difficult. So if anyone is watching this video and is interested or is in Austin and wants to come to have a giant day of engineering, humanitarian engineering, nerd fest ideas, public invention, open source discussion, that kind of thing, please consider coming to Austin, Texas on Saturday, June 13th, where hopefully we'll have some yeah hands by that time. I of course invite Vittorio, although since he's in Italy, it might be quite expensive for him to get here. Marin has posted the Eventbrite registration for the event, and we're really trying to promote it. So even if you can't make it, if you hear of someone in Austin who can come in real life and is tired of being in Zoom meetings and wants to actually see other human beings and see machines and smell ferrofluid and see things get hot and so forth, then please tell them about the Public Invention Demo Day, which will be occurring on Saturday, June 13th. Yes, Megan, go ahead.
If any inventor wants to present as a speaker, also reach out to Dr. Reed or one of his staff members at Outreach at Public Invention or pubinv.org or at the comms email at the same domain, because we can kind of coordinate that and see what material you would want to present. So if you're looking to speak, get with us in advance, hopefully before the end of April, so we can have that scheduled.
Yes, thank you. We have 6 or 7 speakers already, but since it's going to be for a whole day between 9 and 4 p.m., we've got room for more speakers and more projects and allied nonprofits to have tables and perhaps have 5 minutes on stage, etc.